Hey guys, I wanted to go over the week 6 computer assignment with you. And the week 6 computer assignment objectives are we're going to conduct a chi-square test of independence, also known as a chi-square test of association. It's known by both names in many places. Do this in Jamovi. We're going to interpret the results for a chi-square test of independence, report the results for the chi-square test, and I just want to show you a common pattern for conducting most statistical analyses that we're going to follow. They don't emphasize this very much in the text, but there is kind of a general pattern that these things fit into, and it just helps to know the pattern and recognize it when you're learning new tests. So download and open the dataset in Jamovi. So we're looking for the chi-square dataset happiness.omv. And if I'm in Jamovi, go to the hamburger menu, open, browse, navigate to the folder where you have these things. And I have already put this into a Jamovi OMV file and fixed the level of measurement for you. So select the Jamovi file. Oops, that one is the output. That's not the one I wanted to open for you. File, open, browse. I wanted to open the one without the output. Okay. Just to show you guys, if you click on the heading, you can see we have our variables occupation and it identified as nominal, and there's our level statistician and supermodel and happiness. This actually will list it as nominal, and I went and fixed it. And then if you click on the category, you can move it up or down when you switch this to ordinal. And so I had to go reorder these categories because it defaulted to having them in alphabetical order, which is what it often does. So I fixed those for you so we could just move forward. And we're here in the results. I'm going to go to analysis and hit exploration just to get a result started. And you can actually edit, make edits in this output. And so if you click here on this results heading and add your name to the beginning of that. So it's going to appear on your output. And then you can just click outside of it and it'll move. So add your name there in the file or in the output. Okay, you want to use the statistical analysis checklist to help you conduct a chi-square test of independence. So we've been building this checklist throughout the beginning of this semester, and now we're actually going to start using it to help guide us through an analysis. So I know it's been a little tedious adding these sections based on our readings every week, but it's there to help guide us and as a resource throughout the rest of this semester and later on. So the steps are basically the same for most statistical tests, and the specifics just change a little bit. So if you can remember the basic steps, then it's a little easier to fit the new details into the steps that you already know. It is easier than ever to find help with specific details if you know the steps that you want to follow. Truly, as I've played around a little bit, asking questions to chat models, and even Google now will give you the AI condensed version up front in the search results. You can get help and explanations with many of the steps. So it's good just to remember the basic steps you want to follow, and then you can ask questions about the specific details. Checklists are used in many high-stakes environments like aviation and space exploration. They're a useful tool. And my goal is to have something easier for you by the end of this course to help you remind you what you need to do than just picking up the textbook, because the textbook is a lot of information, and unless you go through and kind of reorganize it in a useful sequence, it just takes a long time to read through it. So the checklist is there to be a tool that you can use later on. And I think if I had one goal here is if you're asked to analyze something in the future or critique a study, the first step should be to just get your checklist out and start following the steps. You may not remember how to do a particular thing, but at least you'll have an idea that you know how to do it. And I've taught a good number of students over the years. I was their instructor, and I know what they learned and what they were taught. And after you're out of this course for a semester or two, some of the details get a little fuzzy, and people just kind of forget the steps, and sometimes they don't even know where to begin when they're asked to actually analyze something. So my goal with this checklist is to get you over that hump, and at least get you looking at something that you can do, and you can at least start looking at a couple things and then go get extra help should you need it. So in the checklist, let me bring this up here. Okay, here is our checklist for our week 6 checklist. And as you should recall by now, there's 3 big sections. Section 1 is the study information, the big picture, what's going on with this study. Section 2 is the data set information, basics of what are the variables and things we should look at with these variables before we even start to do any kind of analysis, because we want to find the problems with these things before we analyze anything, because if we don't fix the problems, our results are going to be flawed. And then step 3 is the individual test information. So here we're going to start with the first section, number 1 in the study. And we're just doing learning exercises, but I want you to get in the habit of thinking through these things in your mind as you do this, and start on the big picture and work your way in. And if you get in this habit, you're not going to skip steps. And I'll tell you, it's really easy to forget steps and skip them if you don't just kind of follow this procedure. And I guess my recommendation is to just follow this procedure unless you have a good reason for deviating from it, should something out of the ordinary come up. But in most cases, this is going to help you not miss anything important and make a mistake. So what is the study purpose? So this is results from your Hebe text. It's from her example on page 116. She had you calculate. You don't need to calculate this by hand, but I thought, well, that's a good example. We'll just make up some data that matches what she had for an example, and we'll analyze it. So she didn't give any background on this. There's no fabricated, there's no explanation of if this was a study or not. And all too often, people just skip this step when they're learning, and they focus on just the test. And I just want you to get in this habit of what's the study, what's the purpose here. In this case, let's just be explicit. This is a learning exercise. The data are fabricated, and the results are not generalizable to anything because it's all fake. But if you were looking at real data, you would want to understand this because it's going to be the foundation of the inferences you draw. Research questions, we weren't given one here, but we know that's related to the relationship between spouse's occupation and reported happiness. And there were no hypotheses specified. Study design, there's nothing described here, but we know that groups are compared, so there didn't seem to be any random assignment here, and there's no like control group, so it's probably some sort of a pre-experimental descriptive design, and that's all we can say about it. Ethical considerations, again, this is fake data, so there wasn't anything, but you'd be surprised how many research articles get published and they kind of gloss over that, and they shouldn't. So they should describe it, so you should get used to looking at that. Data collection and handling, again, no descriptions here. This is all fake data, but sometimes people aren't very conscientious about saying, well, how did they collect the data? How did they handle it? How did they make sure there were no mistakes? And that gets glossed over often. So you should get in the habit of looking for that, because it's going to be part of critiquing a study and looking for, is it a high quality study or not? So that's our section number 1, study information. Section number 2, data set information, variables and level of measurement. So we saw in Jamovi that there were 2 variables here, one called occupation, which is nominal, and we know that this is nominal. You know, there's a lot of things here, so it's hard to scroll through, so it's a lot easier to look at this data part with 2 levels, statistician and supermodel. There's no real order there, so it's nominal and happiness. Very happy, pretty happy, happy, not too happy. We identify that order pretty quickly, but Jamovi didn't, so we had to tell it, but it's ordinal. And so we have 2 categorical variables, one nominal, one ordinal. Data accuracy. So you'll notice that it's really easy to fat finger things when you're typing them in. You could have pretty happy and purty happy, but Jamovi doesn't see that, so we're pretty assured that there's no nonsense categories here. Same with statistician and supermodel. So it's good to just double check these things, make sure there's not like a third category actually hanging out there. Data manipulation, there's nothing to do here. We don't have any z-scores to calculate or instruments to sum up. Missing data. So how do we see missing data? We could get some descriptive statistics. So if I go back into this descriptives window, then we can get occupation and happiness, and these are categorical variables, so we want to see the frequency tables, and we can take off the mean, median, min, max, standard deviation there under dispersion, and we can see that we have 1868 observations for both variables, no missing data, and then we have frequencies in percent, so about 91% spouses of statisticians and about 8.6% spouses of supermodels. And then we have a breakdown of how many of these individuals answered very happy, 44%, pretty happy, 38 happy, 12 and not too happy, 5%. So yeah, I don't see any missing data or outliers there. And basic descriptive statistics, we saw those frequencies in percent, kind of the breakdown on both of those variables. So that gives us a nice quick overview. There's no problems to fix. I'm feeling comfortable with moving on with our analysis. Okay, answer the questions in section number 3, test information. So this is where section number 3 deals with an individual test. So this one's going to get updated a little. So the basic sections which we have are not going to really change. This, test selection, independent, dependent variables, and I had you add this section for assumptions of the statistical test this week. So the sections aren't really going to change, but the details and the answers to these are going to change week to week. And I decided to go ahead and just put in the tests that we're working on in that version of the checklist. And that'll be you can go back to whatever version, if you're doing a particular test, and you'll have the checklist that's relevant to that type of test in your notes from this class. So let's just go through those sections, and I've got some answers here for those sections. So these sections: test selection, independent variable, dependent variable, test assumptions, null hypothesis, significant testing steps, post hoc or follow-up, and effect size. Every test is going to have this. It's just the details are going to be a little different. So get used to just looking at this kind of framework. And this is something that I just kind of made for myself as I was trying to learn these things. I don't you're not going to see it like put so concretely in books. And I think that's a bit of a shame because people really need a way to remember, what should they be doing, because otherwise it's just a lot of random things you feel like in your head, and it's really hard to remember particulars. So yeah, I just thought let's just make this kind of standardized and follow along with it. So which statistical test? So we have our table, which you guys made your very first week, because we were learning about levels of measurement, and we learned about independent and dependent variables. And so we made a table that had rows for dependent variables with each level of measurement and columns for independent variable with each level of measurement. And now on our 6th week, we can actually add a test here. So we know we have nominal outcome and a nominal independent variable. And for a chi-square test, it doesn't matter which you call which. It just really depends on how you're going to conceptualize it. And so I put that under the cell for nominal and nominal. And in reality, as you're going to see from our example, ordinal data gets used with this often. There is a kind of chi-square test that deals more specifically with ordinal data. I actually didn't even learn about it in my first statistics courses as a PhD student, but ran across it later in another statistics course. And this is the way it works. You've started learning a set of tests, and you're not going to learn every test here. You might run into something later, and you're just going to have to look it up and then relate it back to the things that you understand, because you're going to have a foundation to understand it. So in reality, you could probably put chi-square test here in the ordinal and nominal sections too, and it'd be just fine. But I thought let's just keep it, cleaner looking. So there's one way to select a test. There's tables like this all over the internet. This is what I learned to do when I was a student, but we have extra tools. So I wanted to show you guys an option in Jamovi to actually help you select the right test. So Jamovi has what they have called modules. So if over here on the right hand side, this big plus sign says modules, click on it, and then you're going to go to Jamovi library, and you're going to go look through this list, and you're looking for one called StatCat, and I already have it installed, so I'm not going to see it here in this list. Oh, I have it in the installed list, and in my installed list, there it is, StatCat. So you're going to look at the available list and scroll down until you find StatCat method selection tool, and you're going to click on the install button, and it takes a minute. And once it's installed, then you're going to find a new menu item called StatCat. So we're working with more than one variable, so we're going to go down here to relationships, prediction, and group comparisons. And we have 2 variables here, and we can just drag one into variable 1 and one into variable 2. And it tells us we entered a dichotomous variable for variable 1, the dependent variable, and an ordinal variable for variable 2, independent variable, and it gave us a chi-square test of association, also known as a chi-square test of independence. I will use these terms interchangeably, and you're going to see them one way in one place, one way in another, so just get used to that. And then it said if you flipped it, you could possibly use a Mann-Whitney U-test. We haven't talked about that. We will. So this is great. You don't even have to memorize like I did. You got a tool here that you can just drag some variables that you have in a data set, and it's going to give you some options of what to do. And then it even gives you a little, kind of like a little mini scatter plot. And these are all categories, and so this little plots are just all concentrated in these little groups. But you'll see here's our supermodel statistician, and then our 4 rank ratings for happiness. And you'll see statistician, by far there were 90% there, and you can see how dark these little squares are, so they're packed in there. And then supermodels were like less than 10%, and you'll see these are smaller, and you can see it's got more over here in the not too happy part than here. So already we're getting a little peek of what's to come and what's going on here. So Okay, well that's nice. We got an extra tool that we can use to look at our uh, test selection. So independent and dependent variable. Um, Again, this is a chi-square test. The results will not be impacted at all by doing it one way or the other. But to make this match the book, I'm going to put happiness in the rows and occupation in the columns. So I'm going to go to I'm going to go ahead and let's go to the analysis part just so I can show you that. So under analysis, frequencies, and contingency test, independent samples, chi-square test of association, that's the one we want. And I said we're going to put happiness in the rows and occupation in the columns. So we already kind of looked at the descriptive statistics for this. We had those there. That's good enough. You know, we kind of looked at it. Okay, now we're down to a new section that we haven't really talked about, test assumptions. So all statistical tests have assumptions, and the extent to which you meet those assumptions, your test will have validity. Depending on how much you deviate, how much your data deviate from meeting those assumptions, the results are going to be less valid or less reliable. So just get used to looking for what are the assumptions of each test as you learn about a test. So here are the assumptions for the chi-square test of independence. So the independent and dependent variables both have to be categorical. And we know this, we looked at the data. This is how you know it, by looking at the data and making sure that it's categorical data. We did that. We know that we have to have independent observations, meaning that observations cannot be related to each other. We shouldn't have like brothers and sisters in there. We shouldn't have the same people looked at two different points. And so the way you usually know this is from the study design. So that's by knowing what the study design was, and you know if you're going to have independent observations. If you had the same group of people and they're looked at time 1 and time 2, okay, we know those are dependent observations. They wouldn't be independent. We couldn't do a chi-square test of independence with them. So that's one reason to know the study design, because that helps you know if you meet an assumption. Mutually exclusive groups. So you should not have anybody that can fall into very happy and pretty happy, both of those. The one of the requirements for this test is that a person can only be in one group for one variable. Same thing with occupation. They shouldn't be both the spouse of a statistician and the spouse of a supermodel, although these days it's entirely possible that somebody could, you could have some supermodel statisticians out there. That's not me, but there might be. So we know our study design. We know that each person's only in one group. And then our expected frequencies need to be greater than 5 for about 80% of the data, 80% or more. And so we don't see the expected values on here. So we're going to go look through a couple of these menus and see if we can add that. So here under the statistics menu, we have a chi-square selected, which we can see on our output. That's great. Your book did talk a little about a continuity correction. If you had a 2x2 table, I believe you could add that. And so you could check the box, but we have a bigger than 2x2 table and we have a large sample size, so we're not worried about that. And then we know that we had some other options here. We're going to come back to that. Cells, here we have our observed counts, and we're going to check the box for our expected counts. Okay, so now you can see that we have some new numbers on our output here, expected, and then we can, if we look at each section, do we have any of these that are less than 5? And as we look at our expecteds, they're all well over 5, so we don't have any problem with having more than 80% of our expected values less than 5. And so here we have 8 cells here, a 2 by 4 table, and 80% would be 4 out of 5. So we couldn't, we could have one of these with less than 5, but going over 2 would be 25%. So that'd be a little too high. So, but we don't have a problem. And we cannot have any expected values of 0. And your books talked about this, and we checked that, and we checked these expected counts, and we don't have any that have an expected value of 0. If you did, then we know that you're supposed to use Fisher exact test instead of a chi-square test of association. So now we can go through and actually conduct our statistical tests. So we're going to follow the null hypothesis significant testing steps. So step 1 is state the null and alternative hypothesis. And so if I were doing this, I've done this a long time, I can do it in my head, but if I was a student, I would actually write it down. And I did right here. The null hypothesis is there is no association between spouse occupation and reported happiness. And the alternative, and all null hypotheses are going to be some form of there's no difference, there's no association, there's no relationship, something like there is no difference there. And that's exactly what we have here for the chi-square test. And the alternative hypothesis, which is marked as H1, there is an association between spouse occupation and reported happiness. So whatever you have for the null, you're going to have the opposite for the alternative. Our criteria for rejection, as it talked about in the book, it's typically alpha 0.05, which is probably what we're going to use for every test in this class this semester. But if you're doing a really important study, you might do alpha 0.01 or even smaller depending on the circumstances and some of the things you're doing. We'll talk a little more about some of those situations later in the semester. Step number 3, calculate our test statistic. So that is what we did right here. And we have our chi-square. We can see a chi-square down here at the bottom. And I'm going to have you add one more thing in here. Down here under nominal, we're going to get phi and Kramer's v. So the effect size for a chi-square test is either going to be phi or Kramer's v. And phi is when you have a 2x2 table, and Kramer's v is when you have anything bigger than a 2x2 table. And you see we have a new little table down here with an effect size. So we have our observed, our expected. You can get percentages. We're not going to do anything with it right here. That's pretty good. I'll just tell you guys. So Jamovi is still a little in development. In some other statistical software, you can get standardized scores for the difference between these observed and expected. And those are kind of nice to see because it helps you identify the places where there's big differences. And kind of like a z-score. Remember a z-score, if you're 2 standard deviations or up or 3 standard deviations, you're getting into outlier territory. A standardized score for these cells would be like a z-score, telling us which ones had big differences. And Jamovi doesn't give us that yet, but we're just going to manually look at that in a little bit. Okay, so, and then we have a decision to make. So are we going to reject the null or fail to reject the null? And in this case, our p-value is much smaller than alpha. It's so small that Jamovi just told us p is less than 0.001, and our alpha was 0.05. So we're going to reject the null in this case, and we're going to, and I would tell students, okay, you wrote down your null hypothesis, go circle the one that you've decided, are you going to go with the null, or are you going to reject the null, and circle the one to make your decision? Because truly following this process and just writing it down will help you keep it straight in your head as you're learning to get used to this. And then we're going to learn what's called post hoc tests later on. And post hoc means after the fact. And there is a bit of a follow-up that we do with the chi-square test, and that is we know there's an association. We know there's differences between these groups, but we need to identify where's the association, what is the pattern here. And so we go through and look at, okay, how big is the difference between the observed and expected values in each of these cells? So I can see my expected was 754 for statisticians and very happy, and 800. Okay, you know, there's a bit of a difference there. But look at supermodels. The observed is 25, the expected was 70. So that's quite a bit bigger of a difference proportionally. And as we go through and look, pretty happy, again, observed was 10, expected was 61. Again, quite a big difference. If we get down here to not too happy for spouses of statisticians, observed was 2, expected was 93. So a lot fewer of these people reported being not too happy than what we expected. And same for supermodels. Observed was 100 reporting not too happy, and we expected 8. So quite a big difference there. So identifying these places where there's a big difference between observed and expected is just identifying, you know, that pattern for the reader. And if it's possible, is there some kind of general trend? And in this case, it is. We can say that overall spouses of statisticians reported more happiness than spouses of supermodels. So that works great. And then what's our effect size? So I already said our Kramer's V is our effect size for a chi-square with a greater than 2 by 2 table. In this case, it's 0.776. And I think I have a slide here about effect sizes. Okay, so I want to just emphasize to you guys that I don't think the book, I know that Heavey didn't emphasize effect size for this at all, which I think is a mistake. Every statistical test has a type of effect size, and we're going to learn different effect sizes for different tests. That's one of the downsides, is each statistical test has its own kind of effect size. But effect sizes, why are they important? And one is they're a way to gauge clinical significance. So if your effect size is big, there's a good chance it's clinically meaningful, and you should pay attention to it as a clinician. P-values are affected by sample size, effect sizes are not. So when you have really large samples like we have here, even small differences are statistically significant, but it doesn't tell you if it's clinically meaningful. The effect size gives you a point or two. Yeah, this is probably clinically meaningful. And so that's why effect sizes were invented, because p-values have this problem. Each statistical test has its own effect size, so we're going to be learning that for each test. In this case, we learned about phi and Kramer's V. There are loose guidelines for interpreting each effect size, but interpretation also depends on domain knowledge. So I think I put it in a slide that for Kramer's V, less than 0.1 is small, 0.1 to 0.3 is medium, 0.3 to 0.5 is large, and 0.5 and above is very large. So I would call this a very large effect size. And it just depends on your field and what's typical. I wanted to point out to you, because I think Heavey has this a bit wrong, and she probably has a viewpoint here, but I don't quite agree with the way she's presenting it in her book. And it's possible to see a large effect size, but no statistical significance if the sample size is small. This may be the case in pilot studies where you're just testing something out and you have a small sample size, or small quality improvement projects, again, where you may not have a big sample size. And so she tries to say that you have to be statistically significant to be clinically significant, and I just don't agree with that, because you can do a small pilot study and get a non-statistically significant result, but a large effect size, and that is a pretty big indicator that that thing is worth studying more and doing a better, a bigger study on. And so I don't really agree with her viewpoint on that. So I've taken out a lot of the quiz questions that she had that in, because I just don't agree with the way she's come at that. And a large effect size might be an indicator of clinical significance, so you should probably pay attention to it. Another reason why it's important is even in pilot studies and quality improvement projects, this effect size actually could be useful to other researchers. And the reason is when, as Hevie pointed out, when somebody is trying to decide to do a study, they should probably do a power analysis to figure out how many people they need to recruit for a study. Well, to do a power analysis, you need to have an idea of what's your target effect size. So a lot of times, if you don't know in your domain what a typical effect size might be, you're going to go look at the literature. And this is where an effect size published in a quality improvement project or a pilot study would be useful to a researcher, because then they can point at that for their power analysis and says, well, we don't have great information, but in this small study, this was the effect size that they found. And they could use that for their power analysis for designing a larger study. So even for just quality improvement projects or pilot studies, publishing that effect size is actually meaningful for further science. And then the other thing is effect sizes are what are used to perform meta-analyses. So when they're going to aggregate multiple studies together, they often use the effect sizes to do that math and to get, if you have 10 studies and the effect sizes from those studies, they can take those and pull those results together and get the effect of multiple studies put together. So having those effect size published means a lot in those situations. So it's good for the science. So I just want to emphasize that to you guys, that these are good to report, and I don't know that that gets emphasized enough in our text. Okay, so report the results. So I had a whole separate textbook in my program that told us how to report results of statistical tests. And this is where we do not need to be creative writers. We need to kind of learn a format and a standard. And I pointed out in the lecture that that Navarro really gave a nice format for writing up some results. If you read Navarro's example in there, it's really easy to follow. I like that. That's probably one of the nicest examples I've seen in a number of textbooks. And I don't think ChatGPT or Copilot does quite as nice a job. But I did kind of summarize this data, and I gave you a prompt here, and I tried it out in ChatGPT, and it was actually not bad. And so if we copy this, whoops, I clicked on the wrong button. I'm going to go copy that text down. Oh, I know what I was going to try. Okay. So I gave you a prompt with a summary here, and I wanted to show you something else I tried, and it actually didn't do too poorly. I was a little surprised that it actually worked. Okay, so if we go into ChatGPT, and I pasted the beginning of that prompt there. Okay, and I'm just going to hit Shift Enter to go down to the next line, and I'm going to go into Jamovi, and I'm going to copy this table here with these kind of descriptive statistics, observed and expected values. So if you right click in there and go copy, and then if you go back into Jamovi and Control V will paste, and it's ugly as all get out. It does not paste a pretty table, but the data's in there. And then I'm going to go hit Shift Enter to go down to the next line, and I'm going to go back to Jamovi again and show you. If you right click and copy the chi-square table here, and we're going to go Control V to paste and scroll down again. It is ugly, it's not pretty, and let's go copy the Kramer's V table and paste that in there and hit enter. Okay, notice how ChatGPT formatted this a little more nicely, although it did leave out the number of participants. So it should have had the number of participants in there. So there should be a comma and equals 1868. So it's not perfect, but darn, that's not bad. I've seen much worse written in published papers. So it gave a kind of an example table there, and you'll need to turn that into an APA table, because Jamovi does give you it as an APA table. But it says these results suggest that happiness levels differ significantly by occupation. Statisticians were much more likely to report being very happy or pretty happy compared to supermodels, while supermodels were disproportionately more likely to report being not too happy. And we didn't give ChatGPT the information that these were spouses of those people, so it didn't have that. The large effect size indicates that the relationship is substantial. Wow, that's pretty impressive for pasting these janky looking tables in there and just a prompt. What I would want you to do is try this out and copy this information out of ChatGPT or whatever chat tool you try, and go down to the bottom of your output and click inside of there. So you'll see that you get the edit menu and your cursor's blinking in there, and Control V to paste the results. I'm not too worried about the table, but the cool part here is you can make notes inside of your output to just help you remember things. And so save that write-up right there. Then it's there with your output. You can save this, come back to it later. And, like I said, this wasn't perfect. It really should have had the number of, and Hevie, I don't like the way Hevie did this. She didn't put the number of participants, but you should have N equals, what I say that was, 1868. Yep. And then click outside of that somewhere. Okay. So, wow, you guys, I would have loved to have this as a student. And I love having this now as this is going to help us do a better job when we're writing things up. So you got to use your head, you got to be smart about it, but what a great tool. Okay. So there's a write-up that looks pretty good. And okay, so you want to, now that you did all this work, go File and Save As, and save this as, I'm just going to save it. I did an output table as I was testing this beforehand, just so that you don't want to lose all this work now that you did it. And you have all these output, and again, remember, you can click back in any of the outputs and go update things if you want to see it slightly differently. But that's there. And then you want to save a PDF of your data file. So go back into Jamovi and go to your hamburger menu, export, browse, go navigate to the folder where you want it to go, and you're going to do a PDF document, and put your name on there and output and export it. Jamovi's going to do its thing, and that is the file that you want to submit in Canvas, is your PDF of your output. Okay, that is the computer assignment. And post any questions if you have them, and I'll talk to you later.